Welcome to the Explainer. Today we're going to do something a little different. We're not just going to talk about AI, we're going to roll up our sleeves and actually build one, right from the ground up. We're going to see how you can take a machine and give it the pieces it needs to go from just computing to actually reasoning about its world.
So that really leads us to the core question, doesn't it? How do you create an AI that doesn't just crunch numbers, but truly understands what's going on? Well, the whole journey starts by giving our machine a place to hold on to what it knows.
You know, any thinking thing needs a brain, right? And our AI is no exception. So the very first component we're going to build is its central knowledge hub. This is where every experience, every fact it learns about the world is going to live.
And that brings us to a really specific kind of AI called a knowledge-based agent. Now, the heart of this thing is what's called a knowledge base, or KB for short. Just think of it like the agent's own private brain, a digital memory filled with logical statements that literally define its reality.
So how does it use this brain? It's actually a really elegant, simple loop. First, it senses the world around it and tells its knowledge base, hey, here's what's new. Then it asks the knowledge base, okay, based on that, what's the smartest thing for me to do now? And finally, once it gets an answer, it tells the knowledge base what it decided to do, and then it acts. It's this constant cycle of perceive, ask, act.
Okay, so a brain is great and all, but it's pretty useless without a language, right? For our AI to really think, all that knowledge we're feeding it needs some kind of formal structure. And that structure is the language of logic.
Now we could start with something simple like propositional logic. Here, every single fact is just true or false. But man, does that get clunky fast. Imagine trying to describe a simple game. You need a separate rule for every single square on the board. The real power, the real upgrade, comes from first-order logic. This lets our AI think about objects and the relationships between them, and that is an absolute game changer.
And this is where you really see the magic happen. Take a look at this one sentence. In first-order logic, this single, elegant rule can replace literally thousands of those clunky true or false statements we would have needed before. All of a sudden, our agent's brain isn't just bigger, it's exponentially smarter and way more efficient.
All right, so our agent's got a brain, and it's got a powerful language to think with. It can represent its world pretty well. But, so what? How does it actually go from just knowing things to doing things? How do we connect all that internal logic to a real-world action?
This right here is the critical leap. I mean, being smart is great, but intelligence is really about using what you know to get things done, to achieve your goals. We've got to connect our agent's brain to its hands and feet, so to speak.
And that's exactly where classical planning comes into the picture. It's the engine that lets the agent look at where it is, look at where it wants to be, and then figure out a step-by-step sequence of actions to get there. To do this, planners use a special language, often something like PDDL, which is basically a way of describing what's possible in the world.
PDTDL works by using these things called action schemas. They're like little recipes for actions. Let's take this example, flying a plane. You have the action itself, fly. You have the preconditions, what has to be true before you can fly, like the plane has to be at the starting airport, and you have the effects, what changes after the action is done. The plane is now at the new airport. It's a simple idea, but with these little building blocks, our AI can now construct some really complex plans.
So, our agent is getting pretty sophisticated. It can reason, it can plan, but as it learns more and more, all that knowledge is going to get messy. It needs a system, a framework to keep it all organized. Think of it like we're building a massive digital encyclopedia for our AI.
And this massive challenge has a name: ontological engineering. It sounds complicated, but it's really the science of defining what exists in our AI's world. It's about creating this beautiful formal hierarchy of every object, every event, every relationship, so that everything has a clear and logical place.
And the scope here is just huge. An ontology covers everything. You start with simple things, categories like pits and wumpuses, but then you move on to objects, events, the concept of time itself, physical parts, measurements. And you can even get into incredibly abstract stuff like mental events and beliefs. It's literally a map of reality for our AI.
So let's just pause for a second and look at what we've built. We have an AI with a knowledge base, a powerful logical language, a planner to create actions, and a whole encyclopedia to organize its world. It's a pretty impressive reasoning machine. But that brings us to the final, really provocative question. With all this structure and logic, what's the one big thing it's still missing to have genuine, human-like common sense? That right there is the next frontier.